Hey everybody, this is Games Plus James and welcome to a brand new series here on the channel where we're going to create our very own top-down shooter. So I've started this new project file here. We've got this kind of basic default view. I'm actually going to move it so we can see both our scene and our game view. So I'm just going to drop this over here like this and we'll split it in the middle just so we can have a bit of understanding of what's going on at various times here while we're making things. So if we're going to make this a top-down game, we're going to need to add some assets to it, obviously. So previously on the channel, we've only really dealt with 2D kind of games. But what we're going to actually start dealing with here is some 3D stuff. Although we're only basically going to be dealing with the 2D axis, we're going to use 3D objects and manipulate things in 3D space. So things will be a little bit different as we go, but nothing too complicated and nothing too crazy. So we're going to first of all add, in 3D objects, we're going to add a plane to serve as the ground, and then we're going to add a capsule to serve as our player. So I'm going to rename this to be player. You can see the player, this capsule kind of starts in the ground here. If I just use the scroll wheel, we can zoom in here a bit. And if you're not familiar with the kind of 3D controls within Unity, there's some handy shortcuts, like if you hold Alt and click and drag, you can spin the scene view around, and you can use the normal kind of movement controls like that as you normally use within Unity. But so our player kind of starts off in the middle of the ground here, so we're going to give him a Y position of 1 to make him pop up just the way we want, and we need to make him obviously stand out from the ground a little bit. So let's go into our assets folder. We're going to create a new folder that we'll call materials, and within that we're going to create a new material that we'll call player. We're going to click on the color over here and we're going to make him kind of a green color. Should do nicely. And then we're going to click this and drop it on top of the player. So now our player is green and he'll stand out in the world. Now the next thing we need to do is if we're going to make this a top-down kind of game, this top-down shooter game, we obviously need our camera to be looking more down as the player. Now we're not going to make the camera be 100% straight down as the player. We kind of want to make it a little bit more interesting. So what we're going to do is grab our camera. We're going to give it a 75-degree rotation. Now our player's disappeared here, but that's because our camera is out of view. If we look in our scene view here, we can see our camera is kind of a bit lost there. So we're just going to click on our movement. We're going to drag the camera up and then drag the camera over, and we'll move the camera up a little bit more. And we'll move it so it's kind of just roughly able to see the player like that. And there we go. We have our player in our view. Just the way we want. So now that we've got this stuff in place, obviously we need to move our player around within the world. And previously in our other series, and what we're going to use here, is we're going to use a rigid body to move the player around. But as I said, we've only used 2D rigid bodies in the past. But now we're going to use a 3D, or not a 3D, but a normal rigid body. So on our player, we're going to go down here, we're going to add component, and we're going to add rigid body to it. So rather than rigid body 2D, just rigid body. And we're going to obviously need our player to move around within the world. So let's go and give him a script to move him around. So in our back in our assets folder, we're going to create a new folder that we'll call scripts. And in here, we're going to create a C# script that we will call our player controller. And then we're going to open this up here in Mono Develop. So we're going to keep it nice and simple for moving our player around, keep it straightforward, but we're going to use not just the default start and update that we have here, we're also going to use fixed update, which is something that is normally used for handling any kind of physics movement within the world. So when you're dealing with rigid bodies and stuff, you kind of want to move the player in the fixed update. And we'll take a look at that more as we go through this script. But to start off with, we obviously need to move our player around, so we need how fast we want our player to move around. So first thing we're going to do is create a public float called move speed. So that'll determine how fast our player can move around. And then obviously, as we've attached a rigid body to the player, we know that we need to be able to interact with that to apply forces so the player can move around. So we need to say private rigid body, and we'll call it my rigid body, just to keep it nice and simple. So then in our start function here, what we want to do is say, okay, the rigid body that we're using in this script should be the rigid body that's attached to the same thing that this script is attached to. So this script will be attached to the player. So we can say we want to get the component that is of type rigid body. So what we're saying is, okay, find the rigid body that's attached to this player, and then that's the one we're going to talk about whenever we refer to my rigid body here. Okay, so in our update loop, obviously here we want to start getting some input from the player to move them around within the world. So what we're going to use is we're actually going to store whatever input is currently being applied into a vector tree, and then we're going to multiply that by the speed, and then we're going to apply that to our rigid body and move it around in the world. So to store it in a vector tree, what we're going to do, I'm deleting things by accident there. What we're going to do is create a private vector tree that we'll call move input. And then down here in our update loop, what we can say is move input is equal to a new vector tree. And the new vector tree that we're creating, obviously it needs to have an x, y, and a z value. And because we're using 3D rather than the 2D that we've done in the past here on the channel, so our x value will be moving our player left to right, which as we've done before. But now the y value won't be just moving the player up and down. Our y value actually moves the player up, upwards into the sky, basically. So kind of towards the camera. So that's not what we want to use here. What we want to use instead is the z value, and z value will move it kind of backwards and forwards in our world. So in our vector tree here, for our x-axis, we want to say input dot get not get key. We want to say get axis raw, and we want to use the horizontal axis. So we're using the horizontal axis to move ourselves along the x-axis. So also, before we go on, we're using get axis raw rather than get axis, and the reason for that is because this is a top-down shooter game, we want very specific controls. So we want, as soon as our player stops pressing any input, the player in the game will immediately stop moving. And if we use just get axis, there's kind of a bit of a slope to the movement, so it doesn't just go from 0 to 1 movement basically. What it does is say, okay, the player has started pressing the button, so we'll kind of slowly move from 0 and 1 being full speed and 0 being not moving at all, obviously. So instead we want to use get axis raw, which means it'll just go 0, 1 straight away, and the player can move around a bit more quickly and a bit more responsive in their movements. So our x-axis is using the horizontal axis, but our y on our player now, like I said, we don't want to use that because that'll be moving our player up into the world. So we're going to leave that at 0f. And then finally our z-axis, we want to use that to move our player backwards and forwards in the world. So for that, we're going to use our input.getAxis raw, and this time we're going to have this be our vertical axis, like that. So we make sure I close all our brackets and put our semicolon at the end. So as I said, we want to use this, now that we've got this vector tree for our input, we want to multiply that by our speed to determine how fast we should be moving our rigid body. So the way we can do that is just by saying, or just very simply, we're going to create a new vector tree up here. Now we could create this down below here, but we're just going to keep this as is a permanent kind of thing being used a lot here. We're going to call this our move velocity. And basically what we're going to say here is just our move velocity is equal to whatever input is currently coming in, so our move input, and we're going to multiply that by our move speed. So now we know how much velocity we should apply to our rigid body to make it move around. So now we need to actually get that going. So as I said, what we want to use is our void fixed, oh, I spelled that wrong, fixed update. And so fixed update, if you haven't encountered it before, is basically the difference between fixed update and normal update here. A normal update happens based on whatever the frame rate of the computer running the game is. So that could vary from 30 frames a second to 100 frames a second. It could be 15 frames a second. Basically, you never know how long an update loop is going to take. Whereas a fixed update will always happen the exact same amount of time. I think by default in Unity it's set to happen every 0.02 of a second. So in our fixed update, basically, we know we can have consistent things always happening. So as such, we can apply any kind of physics forces that we want to apply in our fixed update here. So what we can do here is say, okay, in our fixed update, what we want to do is go to our rigid body, and the velocity on the rigid body, we want to set that to be equal to our move velocity value here. So then if we save this and pop back into the game, we're going to need to attach the script to our player itself. Here, if it wants to finish the compiling, there we go. So we want to add that component. We could click and drag it, but we can also just type in our player controller. Here we go. We need to give it our move speed. And now if we hit play, what we should see is we can now move the player around. As you can see, the player's kind of flopping around all over the place. That's not quite what we want to happen, but it is moving around just like we want them to. So I'm just going to stop this. On our rigid body here, we want to go to our constraints and we hit freeze rotation. What we find is if we play the game again now, our player won't start spinning around as we move around. Nope, he's just perfectly fine staying there like that. Okay, so we've got our player moving around just the way we want to, and the next thing we want to do is basically make the player look at wherever the mouse pointer is within the world. And the kind of one of the most simple and straightforward ways to do this is basically what we want to do is send a line out from the camera itself that will shoot down towards the for all intents and purposes the ground here. So, and it'll shoot down towards the ground, and wherever it hits the ground, basically that's what we're going to make the player himself turn towards and look at. So there's a kind of a few built-in things to Unity to make this kind of a little bit more simple, a little bit more straightforward. So that's what we're going to deal with now. Okay, so back in our player controller script, if we just go just down below where we've handled our input in our update loop, like I said, we want to use basically a line coming out of where the camera is towards where the mouse is in the game. So what we're going to need is a reference to the camera itself. So we're going to have a private camera, and we're going to call this our main camera. And then in the start function, what we're going to say is just our main camera. We want to find whatever is the main camera in our scene. We'll only have one camera kind of operating at a time. So in our main camera will just be equal to find object of type camera. So that'll just find camera within the world, and then we know we're referring to that camera whenever we make a reference to it down below. Okay, so what we can do here, as I said, we want to create like a line coming from the camera, and what that is referred to within Unity is a ray. So a ray is just like a beam coming out of a particular point. So what we're going to use is right here, we're going to say ray camera ray. So this is a new ray that we're creating, and we're calling this our camera ray. And what we're going to say is, okay, on our main camera, we want to use a function that's built into Unity called screen point to ray. And we want to pass into that the position. See, you can see it's looking for a position here, which is basically saying it wants to go from wherever the camera is, it wants to send a ray to a new position. And the position that we're going to use is the current input dot mouse position. So basically what this does is creates a line going from the camera to wherever the mouse currently is within the game screen. Okay, so now that we have that, the next thing we want to do is we want to have that intersect with a flat plane that we're going to call the ground, basically. And like I said, what we're going to do then is find the point where the ray line intersects with the ground, and wherever that point is, we're going to make the player look at that point. So we're going to create a new plane that we're going to call the ground plane. Now we could just have the plane that we've already created here, but this is kind of more of an extra abstract kind of mathematical plane rather than actually a physical thing within the world. So this will be a new plane, which will, we need to pass in 2 values for this plane. Basically we want to have first value be vector3.up. So basically what that means is this is a plane that's just facing straight up, much like our ground plane currently is in the game. And where we want to actually position that plane within the world is just at vector3.0. So we just want to put it at the normal kind of default start point. And the next thing we want to do is create a new float here that we're going to call our ray length, like that. Okay, so this float, it doesn't have any kind of value at the moment, but what we're going to do is give this a value that will basically be how far it is from the camera to the ground. So the way we kind of do that is down here we're going to say we're going to have an if statement, and what we're going to do is create a thing called a raycast. And a raycast is basically something that will kind of determine the length of a particular ray. So we're going to have if a ground plane dot ray cast. So this will actually return true basically if there is a point where the camera ray intersects with something else. So what we're saying here is the ray we're using is the camera ray back up here. Oh, if I could spell it properly we'd be okay too. Camera ray. And if we're just going to type out here, and basically what this will do is it'll say, if we say out ray length, basically what this will do is it'll set the ray length value here to be equal to whatever length it is from where our camera ray starts to wherever it hits another object in the world. So we're going to close that bracket and we'll open a new curly brackets here. So basically what we're saying is if our ray going from our camera, if it hits another object, so raycast is basically, as I said, it's checking to see if a ray hits something else within the world. So if raycast is true, so if our ray goes out and hits something else in the world, which it should do because it's going from our camera to anywhere else in our screen space here. So if that's true, then it'll set the ray length to be however far it is from the camera to the ground. And then we want to actually do some stuff. We want to create a point for our player to actually look at. So we're going to create a vector3 here, which is our point to look. So this will be the point in space that we want the player to actually look at. And we basically just want to set it to be our camera ray, so the ray that's coming out of our camera. On that, we want to get, on our camera ray, we want to get a point. So we want to do camera ray dot get point, and the point along that ray is however far away we've found our intersection, and we know we've set that to be a ray length here. So get point dot ray length, like that, and hit our semicolon there. So basically what's happening now is we've essentially set a point in space for our camera to actually look at, and actually just a way to kind of demonstrate that within the game, if we type debug dot draw line here, what we can do is go from the center of our camera, so the camera ray dot origin, so the start point of our array, and we can make it go, this line go from there to this new point that we've created, our point to look, and we set a color for this line, so we'll make a color dot blue, just for keeping it nice and simple. So I'm going to save this and jump back into the game here. Just let it compile for a second. Okay, if I hit play now, so what we see is on our camera here, Okay, so I'm looking off to the side here. But as you can see, as I move my mouse around, a line is being drawn coming out of the camera to the ground. And so it's basically, it's finding wherever it's intersecting with the kind of mathematical plane. So it doesn't actually matter if I go off this plane here, it doesn't matter. The kind of mathematical plane that we created just is at the exact same level, but kind of goes on for infinity. So wherever we kind of move our mouse, wherever it hits that plane, then it knows how far it's gone. So then we know, okay, we can just that's how we know we can draw this line, because we go from wherever our camera starts and then go out along that line, basically as far as wherever our point is. So now we have a point in space that we want our player to actually look at. So now we need the player himself to actually look in the direction that we want. So I'm just going to stop that. And it's very, very simple and straightforward to actually make the player look around the way we want them to. Basically, all we have to do is say the transform, so that's the transform that's attached to our player. We want to do transform.look at. And basically this just makes it'll just make the player object look at whatever point we want it to, and the point that we want it to look at is our point to look there, like that. Okay, so if we just save this and pop back in, so what we should see is now our player will actually look at wherever we point in the game. So we'll just start this running. Okay, now that we're running, as you can see, our player is kind of, at the moment he's kind of nodding around as he looks, which isn't really what we want to happen. What we actually really want is just the player to keep standing straight up. So we're going to make a change to that now in a second. But as you can see, it is working. Our player is looking exactly where we want him to. So we can stop this running. So back in here, we don't want him to just look at the point to look, because our point to look at is, as we know, right below, or right down at ground level. So what we're happening then is our player is slightly raised above ground level, so he's like ending up looking kind of down a bit. That's why it's leaning forward. So we want to make sure is the player on the y-axis is looking always at the same level. So he's not like looking up or down in space, which is the y-axis. We want him to look at the exact same level the whole time. So instead of telling him to look at point to look, what we're going to tell him to look at is a new vector tree, which will use the point to look value. So our x-axis, we want him to look at his point to look dot x, but on the y-axis we want him to always look at the exact same space the whole time. So what we'll actually use is the player's own transform position. So we can use transform dot position dot y, like that. And then for our z-axis, we want to make sure the player is using the point to look as well. So point to look dot z. Okay, so we'll close that bracket, save that, pop back into the game. That compile for a second. We hit play. And okay, now it's hard to see that our player is actually looking. If I click on the player here, and if I turn on, hold on, just drag. If I drag this over just a bit, if we turn on gizmos here, there we go. So we get the kind of outline on the player. So as you can see, he is still moving around, and we can move around our player in the world. And if we leave our mouse where it is, the player will turn and face that mouse as we move around. So perfect. Our player movement is all kind of handled, and our player facing the direction that we want is working just the way we want as well. So there you go. Now we have our player kind of moving around. The next thing we want to do is add the ability to actually fire our weapons. So we're going to create a nice little weapon and learn how to shoot that gun in the next episode. So thanks for watching, and I will be back soon with some more top-down shooter tutorial goodness. Thanks for watching this episode, and if you want to learn more about developing your own games, you can follow the link on screen to my complete 2D platformer game development course on Udemy, where you will learn how to program and build a complete game in Unity 2D with multiple levels, enemies and unique boss battles. So click the link on screen or in the description below and get the course today.